Welcome, agents, to your next mission. You are stepping into an explainer designed specifically to crack the code on Cambridge AS and A-Level Computer Science Syllabus 9068. But listen, whether you are tackling 9068 or building your foundations in 0417, 0478, 0983, 0984, or 2210, the extraction strategy we are deploying today is universal. Your mission, should you choose to accept it, is to extract maximum marks from a hostile exam paper in 20 minutes or less. Today, we are zeroing in on one of the most notoriously tricky extraction points, justifying compression methods for given situations. Now, to understand the stakes, let me introduce you to two operatives we see all the time. First, there's Alex. Alex overloads every answer with raw computer science facts, just totally dumps a textbook onto the page with absolutely no analytical focus. Then we have Sam. Sam rushes the extraction, completely missing the command word requirements of the prompt. We were looking at a real Cambridge past paper question just recently, code 9713, and seeing their answers side by side with the examiner's red pen marks was brutal. It was a bloodbath of lost marks. If you've ever stared at a past paper scenario and wondered exactly what the examiner is looking for, you are in the right place. We are going to deconstruct the theory, the methodology, and the hidden traps that catch out even the best candidates.
Okay, look at this powerful intel straight from the principal examiners. It perfectly sets the stakes for how we are going to secure those top marks today. It is incredibly frustrating to know the computer science theory inside and out, but still miss out on points purely because of how you structure your justification. The examiners themselves are literally telling us that these are easy marks being left on the table. Both Alex and Sam lost points here, not because they didn't understand what compression was, but because their strategy was fundamentally flawed. Our mission today is to turn this widespread weakness into your absolute biggest competitive advantage on exam day.
To execute this extraction, we'll hit 4 checkpoints: core principles, procedural methodology, critical analysis, and finally, top examiner warnings.
Checkpoint 1. Core principles.
It's a fantastic question, isn't it? The examiner reports constantly highlight this exact hurdle. Candidates will memorize how compression works perfectly, just like our agent Alex, who can recite the definition of run-length encoding in his sleep. But the very second they are presented with a completely new scenario, like, say, a unique business problem or a strange data transmission requirement for a hospital network, they completely freeze. The sources tell us this stems from a lack of connected, conceptual understanding. Cambridge isn't just testing if you know what lossless or lossy means. They are testing if you can parachute that theoretical architecture into a real-world, highly unfamiliar context. Alex fails because he just writes down what lossless compression is, completely ignoring the hospital scenario. Sam fails because he rushes past the specific constraints of the prompt. To survive, you have to connect the dots.
Now, this is where we reveal the true strategy. Candidates who explicitly reference cross-topic connections achieve significantly higher marks. It's not enough to work in a silo. Your theoretical architecture must rest on precise definitions, establish clear causal relationships, and show seamless integration with other syllabus areas. To do this, top students use the PEAL framework: point, evidence, explanation, link. Your point is your precise definition. Your evidence and explanation build the causal relationship, and your link integrates it back to the specific question or other syllabus areas, like networking or data structures. When you justify a compression method, you need to prove that if you compress the file a certain way, a specific outcome happens. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's keep moving.
Every single mission objective or question you face will target these distinct cognitive domains. You must systematically demonstrate knowledge, apply it, and then analyze. This is exactly where Sam rushes and messes up. Sam misses the command words that dictate which of these objectives is being tested. You must first demonstrate your fundamental knowledge. Then you apply that knowledge to the specific constraints of the prompt. Finally, you perform an analysis. When justifying a compression method, your reasoning must be evidence-based. You can't just throw out a statement like, lossless is better. Why is it better? You have to prove why it's better for this specific data based on these core assessment objectives. I want you to mentally look at your past answers. Can you spot which of your paragraphs actually follows that PEAL framework to hit all 3 of these objectives? If you can't, that's where your marks are bleeding out.
Moving to checkpoint 2, procedural methodology. This is the transformation. Top-performing students use a strict deconstruct, solve, evaluate framework. Whenever you drop into a compression justification problem, stop. First, identify the key elements and constraints given in the information. Second, break the problem into a logical step-by-step decomposition. Third, solve it systematically by applying relevant principles. Fourth, verify your results, check for reasonableness. And finally, step 5, present your justified recommendations in an appropriate format. When we sat Alex and Sam down to rewrite their flawed past paper answers live using this exact framework, the transformation was incredible. We watched the examiner's red pen marks literally turn into green check marks. Alex stopped overloading facts and started logically evaluating. Sam stopped rushing and started systematically identifying the given information. This 5-step standardized sequence is your ultimate safety net during the exam extraction. To lock this procedural sequence into your brain when you are under intense exam pressure, I highly recommend using a visual story method to encode the steps. Imagine you are a secret agent on an extraction mission. You first gather the enemy intel, that's identifying information. You lay it out on your tactical board, breaking it into logical steps. You follow the infiltration track systematically. You pause to ask if the escape route is reasonable, and finally, you confidently present your mission debrief and recommendations to headquarters. By encoding justifying compression methods into this visual narrative, you ensure you won't skip a crucial step when you only have 60 seconds to formulate your first rewrite attempt in the exam hall. Let's breach checkpoint 3, critical analysis.
Stop scrolling, subscribe to our YouTube channel, Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's dive into an interactive workshop right now. Evaluating algorithm quality isn't just about the main function. It's about rigorously testing 3 highly specific performance metrics. When you are justifying why a specific compression algorithm is the right choice, your critical analysis must look at time complexity, meaning how long will this take to execute, space complexity, how much memory overhead is required during the actual compression process, and crucially, edge cases. Imagine a complex computer science data table showing compression ratios across different file types. If you only had 60 seconds to scan that data, could you extract the core trend? You need to quickly identify what happens when the algorithm encounters highly repetitive data versus completely random data. Explicitly stating these factors and their effect on performance is exactly what separates a good operative from a master agent.
Final checkpoint, Section 4, Top Examiner Warnings. Examiners have identified 3 massive, repetitive mistakes that consistently, year after year, cost candidates their grades. By knowing exactly what the examiners are tired of seeing, you can ensure your mission is a success. Let's look at these 3 major pitfalls and test your ability to spot them. The first major pitfall is that students completely confuse the cause of a compression issue with its resulting effect when trying to justify their methods. Let's do a Find the Flaw challenge. Imagine reading this sample paragraph. The file taking longer to send causes it to be larger, therefore we need lossy compression. Did you spot the sentence losing marks? The flaw is backwards logic. The large file size is the cause, and the slower transmission speed is the effect. When you mix up the causal relationship like that, your entire justification falls apart, and examiners are forced to deduct marks. They literally write notes about this in their reports. Always be exceptionally clear about what is triggering the problem and what the resulting consequence is. Let's move to the second warning. This is where Sam always trips up. Failing to check boundary conditions, which leaves the algorithm evaluation dangerously incomplete. Examiners report that students often only test or write about the happy path, the standard expected data. But think about the edge cases. What if the compression method encounters a file that is already compressed? What if a lossless run-length encoding algorithm is applied to a string with absolutely no repeating characters? If you forget to evaluate these extremes, your justification is critically weak. Always prove to the examiner that your strategy accounts for the boundary conditions. Now for Challenge 3, speed writing. This is the biggest warning. Providing a textbook definition won't save you if you don't apply it directly to the unique context presented in the prompt. If the question asks about compressing medical MRI scans for a hospital database, do not pull an Alex and just write a generic essay about how lossless compression retains original data. You have 30 seconds to write a perfect Peel paragraph. Point: lossless compression. Evidence: MRI scans require exact pixel recreation. Explanation: any loss of data could lead to a fatal medical misdiagnosis. Link: therefore, it perfectly satisfies the hospital's strict database integrity constraints. Context is king. If your answer could apply to any scenario, it scores 0 for application. This brings us to the final system for extracting maximum points. Even if your final algorithmic answer is completely wrong, demonstrating your systematic process through clear working can rescue vital method marks. We call this the method mark strategy. It relies on 3 rules that guarantee top marks. First, command word decoding. Know exactly what action is required. Second,
PEL framework application. Structure your logic perfectly. And third, a time management matrix. Allocate your minutes based on the mark value. If you make a math error or select a slightly less optimal algorithm at the end, but your systematic processing, step-by-step decomposition, and clear working are laid out clearly on the page, the examiner will reward your process. Never just drop the final answer. Document your entire analytical journey to secure those safety marks.
Armed with this complete deconstruct, solve, evaluate playbook, I leave you to consider how you will systematically extract every possible point on your next paper. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at aceexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.